Okay, this lesson is about solving a quadratic. When we say solve a quadratic, or we want to find the solution of a quadratic, we are looking for the x value when y equals 0. Now, we're looking for the x value when y equals 0 because the equation is set equal to 0. Alright, so that's one of the reasons we call them zeros, because remember the x value is the x-intercept when y equals 0. Now, we're going to call that a real solution or a real root, and the reason for that is because we're finding solutions, x-intercepts, that are real numbers. Real numbers are those positive and negative whole numbers, which we call integers. They are also decimals and fractions. They're all the numbers on the number line. So before we can find a solution of a quadratic, we need to always set the equation equal to 0. So if you have the equation f of x equals x squared plus 16, before we solve it, we're going to replace that f of x with a 0. Because that's what we're looking for, is when the y, what is the x value when the y is 0. Okay? Now, since we are talking about possible real solutions, we've got to be sure that we understand what a real number is. So on your number line, you have 0 in the middle, you've got a positive 1 this direction, you have a negative 1 this direction. All of the decimals and fractions in between here and all the whole numbers are real numbers. If it's not on the number line, it's not a real number. So there are 3 different scenarios that we can solve, 3 different scenarios for solutions that we can get when we are dealing with a quadratic. So the first situation is what we call 2 distinct real zeros. Now, we've looked at this before. This is when we have 2 x-intercepts. It is crossing the x-axis 2 times. This terminology is something that you will probably see on like the ACT. So we're getting you used to the terminology. Distinct just means specific. Okay, so there are 2 specific roots. Real meaning they're actually on the x-axis, so they're real numbers. Alright? Now, there's also the situation of 2 non-distinct real solutions. Non-distinct means they're not different. Now, we looked at this scenario before also. If I can draw this, just a minute. There we go. 2 non-distinct real zeros means that there's only one x-intercept. So why do we say that there's 2? Well, that equation is going to look something like f of x equals x plus 4 times x plus 4. So when you're looking at that factored equation, see if I can move this up. When you're looking at that factored equation, what are your x-intercepts going to be? Well, they're going to be negative 4, 0. And in this second parentheses, that also represents negative 4, 0. So there are 2 of them in the equation, but it actually represents 1 point. That's 2 non-distinct or not specific real roots. They repeat each other. Okay, the last situation is when there are no real roots. Why do we have to say there aren't any real roots? Well, because the reality is there are roots and solutions, but they are not real numbers, and we will learn what other kind of numbers there are in a few lessons. Alright, so these are the 3 situations we have. So now let's look at the ways we can find real solutions. Okay, you guys know this one. We can factor. Now, what you need to know about factoring is this only gives us solutions that are integers, and integers are positive and negative whole numbers. Okay? So if we need to find the real solutions of f of x, I am going to factor this trinomial into x. I've got to have the same signs, and they're both going to be negatives. Factors of 24 that will add up to 10 are 6 and 4. So my solutions are positive 6, 0 and positive 4, 0. Okay, 6 and 4 are integers because they're positive whole numbers. All right, you cannot find anything but integer solutions with factoring. The second way we can find real solutions is with the quadratic formula. You guys remember this, you learned this in Algebra 1 and in geometry. This can give any, oops, didn't get my pen back, this can give us any kind of number solution. So that includes integers, decimals, but it also includes imaginary numbers, and we haven't learned about imaginary numbers yet, but we will. So we all remember the quadratic formula. So the quadratic formula, if you remember, is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And this can give you both real number and non-real number solutions. Now, let's just remember that we get those letters from our standard form of a quadratic. Okay, so in this situation, I would do x equals negative 3, because 3 is my b value, plus or minus the square root of 3 squared minus 4 times a, which is 2, times negative 6, I'm running out of room, which is the c value, a and c, all over 2 times the a value, which is 2. Okay, we can put that in our calculator. So when we plug that into our calculator, we end up with x equals 0.98 and x equals 2.48. Now the third way of finding solutions to a quadratic, if we have a situation where we have x squared minus a number, we can always just add that number to the opposite sides, and we get negative 4 equals x squared, and then we're going to take the square, oops, sorry, that was supposed to be a plus 4. We added 4 to both sides, apologize for that. We are going to take the square root of both sides. Well, the square root of x squared is x. The square root of 4, when we're dealing with quadratic solutions, we are going to consider both the positive 2 and the negative 2. So positive 2 times positive 2 equals 4, but negative 2 times negative 2 also equals 4. So that's another way that we can find solutions. And then the fourth way is just to use our calculator. Now this is for any real solution. We'll just graph it, and we will find the zeros using our second trace. Zeros, we go to the left and the right side of each one, or of the point that we want, and hit enter a few times, and it's going to give us our zeros. But that's for real solutions, not imaginary. Alright, so those are the 4 ways that we can find quadratic solutions. Alright, the last thing is the discriminant. You should have seen this last year. It's b squared minus 4ac. Now, if you remember from the last screen, b squared minus 4ac is what is in the square root sign of the quadratic formula. Now, the thing you've got to understand is that the discriminant is only to find out how many real solutions. It doesn't tell you what the solutions are. But if you're looking for real solutions, doing the discriminant first can keep you from wasting time, because it tells you if there's not going to be any. Alright, so it does not, let's go ahead and do a quick example. Here we have 0 equals 2x squared plus 3x plus 6 instead of minus 6. So I'm going to do 3 squared minus 4 times 2, which is the a value, times a positive 6, which is the b value. But notice we're not using that square root sign because we're looking for the discriminant. So this is going to be 9 minus 48. 9 minus 48 gives me a negative 39. So what is the discriminant telling us? If b squared minus 4ac is less than 0, or it is a negative number like we've got right here, there are no real solutions to that quadratic. If b squared minus 4ac is equal to 0, then there is exactly one real solution. And if b squared minus 4ac is greater than 0, where the number is positive, then there will be two real solutions. So this just keeps you from doing more work than you need to. If it ends up being a negative number, there's no real, and you don't need to keep going with the process if you're only looking for real solutions. That's all we've got for today.